So margins related to derivatives are an average rate of change when the change is 1 compared to the instantaneous rate of change. So what we're going to do here is we're going to compare C prime of x, the derivative. Right, so the derivative of cost per unit, and that is per additional stuffed alligator toy that we make. So that's the derivative, that's the instantaneous rate of change. And often in finance, we use derivatives to estimate margins. Now, margin is actually a per unit change. So the marginal change is technically the cost at whatever x value you want, but we produce one more and see what happens, compared to the cost of only, oops, and that should be a minus because we're looking for a change, of producing x units. And if you consider what's the change in x here, well, I just increased by x by 1, so that's divided by 1. All right, my x2 minus x1, x plus 1 minus x is just 1. So technically, it's just the difference between producing 1 unit more. So in this problem right here, I'm asked to calculate at 1,001 units versus 1,000. So if x equals 1,000, my marginal change is, well, find the cost at 1,001 units and find the cost at 1,000 units and subtract them, and that's the marginal cost when x equals 1,000. We're going to compare that result there to the instantaneous rate of change. Instantaneous rate of change, my C prime here, let's see, x squared derivative is 2x times 4 thousandths would be 8 thousandths. So 0.008x plus derivative of 10x is 10, derivative of 8,000 is 0. So that right there is my instantaneous rate of change. And if I find that at 1,000, so C prime at 1,000 is just to plug into that formula right there. And the point I want to make here is finding that derivative wasn't very hard in this example, and plugging into that is pretty easy arithmetic. On the other hand, plugging in 1,000 into this, then plugging in 1,001 into that, and then subtracting those, that's a lot of work. It's way more complicated to compute with this polynomial twice and subtract than it is to have the derivative and then just plug in 1,000. Are these two numbers going to be exactly the same? The answer is no. One is an average rate of change over a change in 1. The other is the instantaneous rate of change. Let's look at this on a graph on the calculator. And Desmos is our friend here. Let's reset. There's the reset button. I thought Desmos had a reset. Let's just do that. All right. So my cost function C of x is equal to 0.004x raised to the second power plus 10x plus 8,000. And by hand, calculating with that is a little bit of work. Its derivative, let's call it m for margin, the marginal cost we just calculated is 0.008x plus 10. A little easier to work with. So the marginal, the instantaneous rate of change at 1,000 units is just m of 1,000. That's 18. The marginal cost is to actually calculate the cost of 1,001 items and subtract the cost of producing 1,000 items. So margin means change in one item. And notice that they're close, but they're a little bit different. And again, my point is this computation is a wee bit more work than this computation right there when I just plug in 1,000. If we have the marginal, if we have the average rate of change, okay, now it could be the function is too complicated to work with, in which case we do want to do this arithmetic down here. All depends. But we have two different ways, and they're always going to be very, very close to each other. All right, so that's marginal cost, derivative of cost, change in 1 unit over time.